Good morning, sir. I'm Y Nikita from EC Department B section. My roll number is 21951A04C2. My topic for maths is modal matrix of diagonal matrix. Eigenvalues and eigenvectors. Eigenvector of a matrix is a vector represented by a matrix X such that when X is multiplied with matrix A, then the direction of the resultant matrix remains same as vector X. Mathematically, above statement can be represented as Ax is equal to lambda x. When A is an arbitrary matrix, lambda are the eigenvalues and x is the eigenvector corresponding to each eigenvalue. Here we can see that Ax is parallel to x. So, method to find eigenvectors and eigenvalues of any square matrix A. We know that Ax is equal to lambda x. So, Ax minus lambda x is equal to 0. A minus lambda I into x is equal to 0. Above condition will be true if only A minus lambda I is singular. That means A minus lambda I is equal to 0. Equation 2 is known as the characteristic equation of a matrix. The roots of the quadratic equation are the eigenvalues of a matrix. Now, to find eigenvectors, we can simply put each eigenvalue into 1 and solve it by Gauss elimination method. That is, convert the augmented matrix A minus lambda I is equal to 0 to row echelon form and solve the linear system of equations thus obtained. Some important properties of eigenvectors, eigenvalues. Eigenvalues of a real symmetric and Hermitian matrices are real. Eigenvalues of real skew symmetric and skew Hermitian matrices are either pure imaginary or 0. Eigenvalues of unitary and orthogonal matrices are of unit modulus mod lambda is equal to 1. If lambda 1, lambda 2, or lambda n are the eigenvalues of A, then k lambda 1, k lambda 2, k lambda n are eigenvalues of Ka. If lambda 1, lambda 2, lambda n are the eigenvalues of A, then 1 by lambda 1, 1 by lambda 2, 1 by lambda n are eigenvalues of A power minus 1. If lambda 1, lambda 2, lambda n are the eigenvalues of A, then lambda 1 k, lambda 2 k, lambda n k are the eigenvalues of AK. Eigenvalues of A is equal to eigenvalues of A transpose. Sum of eigenvalues is equal to trace of A, sum of diagonal elements of A. Product of eigenvalues is equal to lambda A. Maximum number of distinct eigenvalues of A is equal to size of A. If A and B are two matrices of same order n, then eigenvalues of A, B is equal to eigenvalues of B and A. Modal matrix. The modal matrix is used to diagonalization process involving eigenvalues and eigenvectors. Specifically, the modal matrix M for the matrix A is the n into n matrix formed with the eigenvectors of A as columns in M. It is utilized in the similarity transformation. D is equal to M inverse AM, where D is an n by n diagonal matrix with the eigenvalues of A on the main diagonal of D and zeros elsewhere. The matrix D is called the spectral matrix of A. The eigenvalues must appear left to right, top to bottom in the same order as their corresponding eigenvectors are arranged left to right in M. The matrix A is equal to 3, 2, 0, 2, 0, 0, 1, 0, 2 has eigenvalues corresponding to eigen lambda 1 is equal to minus 1, lambda 2 is equal to 2, lambda 3 is equal to 4, b1 is equal to minus 3, 6, 1, b2 is equal to 0, 0, 1, b3 is equal to 2, 1, 1. A diagonal matrix D is similarly D is equal to minus 1, 0, 0, 0, 2, 0, 0, 0, 4. One possible choice for an invertible M is equal to minus 302, 601, 111, that is matrix diagonalization. Let A and B two matrices of order n. B can be considered as similar to A if there exists an invertible matrix P such that B is equal to P inverse AP. So this is known as the matrix similarity transformation. Diagonalization of a matrix is defined as the process of reducing any matrix A into diagonal form D as per similarity transformation if the matrix A is related to D, and then the matrix A is reduced to diagonal matrix D through another matrix P, which is P is model matrix. D is equal to P inverse AP. In simpler words, it is a process of taking a square matrix and converting it into a special type of matrix called the diagonal matrix. Steps involved. Step 1. Initialize the diagonal matrix D as D is equal to lambda 1 0 0, 0 lambda 2 0 0 0 lambda 3, where lambda 1, lambda 2, lambda 3 are the eigenvalues. Step 2. Find the eigenvalues using the equation given below. Det of A minus lambda I is equal to 0, where A is given 3 by 3 square matrix, I is the identity of the size of the 3 by 3 matrix, lambda is the eigenvalue. Step 3. Compute the corresponding eigenvectors using the equation below. At, lambda is equal to I. A minus lambda I xi is equal to 0, where lambda I is the eigenvalue, lambda xi is the corresponding eigenvector. Create a model matrix P is equal to x0, x1 till xn. Here all the eigenvectors till xi are filled column-wise in the matrix P. D is equal to P inverse AP. Step 5. P inverse, then find P inverse and then use the given equation to find the diagonal matrix D. Example problem. Find the diagonal matrix D of A using the diagonalization of a matrix. D A is equal to 1 0 minus 1 1 2 1 2 2 3. D is equal to P inverse AP. Solution. Step by step solution. Step 1. Initialization. D is equal to lambda 1 0 0 lambda 2 0 0 0 lambda 3. Find the eigenvalues. So det A minus lambda I is equal to 0, where det A is 1 minus lambda 0 minus 1 minus 1 2 minus lambda 1 2 3 minus lambda. So get the equation. Lambda cube minus 3 6 lambda square plus 11 lambda minus 6 is equal to 0. Lambda minus 1, lambda minus 2, lambda minus 3, lambda is equal to 1 2 3. Find step 3. Find the eigenvectors x1, x2, x3 corresponding to the eigenvalues. At is equal to get x1 1 minus 1 0 minus 1 1 2 minus 1 1 2 2 3 minus 1 x1 x2 x3. You get, on solving we get the equations. X3 is equal to 0 into x1 plus x2 is equal to 0, x3 is equal to x2 minus equal to minus x1, x1 is equal to x1 minus x1, 0 into x1, so x1 is equal to 1 minus 1 0. Similarly lambda is equal to x2 is equal to minus 2 1 2, and for lambda is equal to 3, x is equal to 3 1 minus 1 2. Similarly for lambda is equal to 2 and the lambda is equal to 3, x2 is equal to minus 2 1 2, lambda is equal to 3, x3 is equal to 1 minus 1 2. Step 5. Create a creation of model matrix P. Here x1 x2 x3 are column vectors. P of x1 x2 x3 is equal to 1 minus 1 0 minus 2 1 2 1 minus 1 2. Step 6. Finding P inverse and then putting values in diagonalization of matrix. P is equal to 1 minus 2 1 minus 1 1 minus 1 0 2 minus 2. Det of P is equal to 1 into minus 2 into 1 is P is not equal to 0, so matrix is immutable. We know that P inverse is equal to adjoint P into det P. On solving we get P inverse is equal to 1 by 2 into 0 minus 2 minus 2 minus 2 minus 2 minus 2 is 1 0 minus 1. Putting diagonalization matrix we get P D is equal to P inverse AP. D is equal to 1 by 2 into 2 0 0 0 4 0 0 0 6. So D is equal to 1 0 0 0 2 0 0 0 3. Hence the matrix is diagonalized. Thank you, sir, for giving me this wonderful opportunity of sharing my views on matrix diagonalization. Thank you, sir.